Okay, well, welcome back. We're moving on to problem 3. Okay, we were talking about writing in scientific notation, so now we're going to talk about standard notation. So we have a weight in an elephant is 5.5 times 10 to the 6 grams. We want to write that as standard notation. Standard just really means to write it in a regular format that you would see pretty much all numbers. So we're going to write the 5, the 55, all the non-zero numbers. Then what we're going to do is, since it's a positive 6, we're moving it to the right. Okay, so we're going to move it over 1. There's 1 place to get it to 55. And then after we move it past all the non-zero numbers, that's how many zeros we're going to have left. So I moved it 1 spot, I have a 6. So I drop that to the 1 spot I used. I'm going to have 5 zeros. Okay, so there's 5 zeros. If I count it out, there's 2, 3, 4, 5, and 6. That's where my decimal is going to go. Now I don't need to write that, the decimal at the end of this, unless there was some non-zero numbers there. So there's another 0 there. There would be my number in grams as I would write. So again, I move it 1 spot. That takes one of these away. Means I have 5 left. That's how many zeros. If it was only 5 times 10 to the 6, then there would be 6 zeros. So let's look at the weight of an ant. 3.1, so I'm going to write my 31. My decimal's here, but I'm going to move it, it's negative, so I'm going to move it backwards. So there's 1, and then kind of the same process. I took 1, so that drops me down to -2. So that means I'm going to have 2 zeros. And if I count it out, there's 1, 2, and 3. So that means my decimal is now going to go there, making this 0.0031 grams. So an ant weighs 0.0031 grams. Okay, so again, 1 spot back, since it was negative, it drops me down to a -2. I have 2 more zeros. Okay, so got it, number 3 again. Go ahead and do this, and we'll check that at the end. Alright, let's look at example 7 here. Ordering these, so I'm going to give you kind of the different ways to do this. So when I look at this, I have states, Georgia, Montana, Ohio, and Rhode Island, and they have an area provided here in scientific notation. Now I want to put these in least to greatest. Okay, so as I go least to greatest, the first thing I can do is I can look at, as long as they're all in scientific notation, I can look at their exponents. So the smallest one obviously is going to be the one with the smallest exponent. So each of these are 5.9, 1.5, 4.5, 1.5, all in scientific notation. So therefore I know that 1.5 times 10 to the third is my smallest. Now I have a tie with my exponents with Georgia and Ohio. So now I move to their numbers. So 5, 4, well, that means Ohio is smaller with 4.5 times 10 to the fourth. Okay, and then Georgia's 5.9 times 10 to the fourth. Okay, so I looked at the exponents, they were tied, so I went to the numbers and I said, hey, 5 is bigger than 4, so therefore that has to be larger. And then that just leaves Montana with the 1.5 times 10 to the 6. So it's real quick. You don't have to put it in standard notation. You can actually just compare the exponents. Alright, so problem 5, we get a different type of least to greatest. Now as I look at this, I see, hey, these are not all in scientific notation. So what I'm going to have to do is I'm going to have to change it. So I'm going to change 49.7. I'm going to make this 4.97. Okay, so if I change this number, I'm just going to make this part in the scientific notation. That means I need a times 10 to the first to get it just back to here. Okay, just back to 49.7. So I still have this 10 to the 7th, so I'm just going to bring that down. Well, I have another 10 to the 7th, which that means this gives me 4.97 times 10 to the 8th. So I've just put this in scientific notation. Now I'm going to do the same thing for this one. I'm going to make it 4.7 But to make 4.7 back to the original, I have to make it times 10, and I'm going to have to move it 2 spots back, so that's -2. Now again, that's just this number. So then I have to times 10 to the 9th. Alright? So now I have, and I'm actually taking away, so it's negative, so I'm taking away, so it gives me 4.7 times 10, and 9 minus 2 is going to give me the 7th power. Now the last one, you're just really writing it in scientific notation, which means 4.95 times 10, and to get it back to the original, it would have to be the second. So there it is now, all in scientific notation. Now you go standard notation on this as well. Some students like to do that, and that's fine. You're just going to sometimes be dealing with some really big numbers. Okay, so I look at the exponents now, and I see that, hey, 4.95 is my smallest. So I'm going to go ahead and I'm going to write my answer as 4.95 times 10 to the second is 495, because I want it what the original numbers were. That's the key, is we have to use the original numbers. So my next one, as I look, it actually turns out to be this 4.7 times 10 to the 7th. So therefore I use 0.047 times 10 to the 9th. Okay, so notice that the exponents, you can't look at them in this case, which means that 4.97 times 10 to the 8th is actually the largest, which is 49.7 times 10 to the 7th. So I want this bottom row to be my actual answer, okay, not this middle row, because that's what I changed in the original problems when I need to answer. Okay, so got it, number 5. I want you to go ahead, give that a shot, try that, okay, and I'll show you here real quickly what the answers would be. Okay, so there's your answers for all your keys, or for all the examples that you should have been doing on your own. See how well you did. If you have any questions, let me know. We'll pick up with that tomorrow in class with the quizzes, and make sure you do your Edmodo. Alright, have a good night.